Hi everyone. Well, I know we've already proved the vertical angle theorem, but I want to talk a little bit more about it and how we can use the vertical angle theorem. All right, so the vertical angle theorem says that if two angles are vertical, then vertical angles, let me get my colors going here, then vertical angles are congruent. And you guys have been writing equations from vertical angles, and I've been asking you what theorem justifies your solution, and I've allowed you to say either vertical angles are congruent, you can say that, or if you feel more comfortable, you can say the vertical angle theorem, or you can say that. You can use that. All right, well, let's use the vertical angle theorem. So I want you to get out your highlighter. Now, remember, we look at a proof, we have a given, a proof, and usually a diagram. And right now we're doing a two-column proof. So we're going to have one side that says the statements, one side that says the reasons. So every statement has to have a reason, which would be a definition, a postulate, or a theorem. All right, so first thing that I always want to do is I want to mark my diagram with the given. And then I look at what I'm trying to prove. All right, well, the given is that angle 2 equals angle 3. Okay, and then when I look at what I'm trying to prove that 1 equals 4. I actually put a little placeholder dot for myself. I want to prove those guys are equal. Well, right there, I kind of notice that 1 and 2 are vertical angles, so they're congruent. And I notice that 3 and 4 are vertical angles, and they're congruent. So that leads me to believe then that 1 equals 4. Which is what I'm trying to prove. But I actually have to formally state that. So remember, we're going to start with our given, that angle 2 is congruent to angle 3. And our reason for that, because it was given to us. All right, from there I can go to the diagram because there was no other given information other than the diagram. And I can say that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. Now, you could put them next to each other, you could put them up over each other, it doesn't really matter. All right, and that would be why? Well, because of the vertical angle theorem. All right, but now I've got to connect. Because I'm trying to prove that 1 equals 4. Well, I can see that if 2 equals 3 and 1 equals 2, then 1 equals 3. So angle 1 is congruent to angle 3, and that's the transitive property. Remember, we're plugging one thing in for another. It's almost like substitution twice. All right, well, if 1 equals 3 and we know that 3 equals 4, then angle 1 is congruent to angle 4 by substitution. All right. Now, 1 and 3 we were connecting. You probably could get away with using substitution there as well. Remember, I told you transitive is kind of like double substitution. So right now I'm going to kind of accept either of these. But let's move on, okay? So hopefully, and we got to what we were proved, so we were done, okay? So once we get to what we're proving, we're done. All right. So a couple review questions. You can see that I gave you some review questions. They are completely up to you if you feel like you need more problems with supplements and complements. But I decided to quickly write an equation for number 5. So it says the supplement of an angle is 4 times the complement of the angle. Find the measure of the complement. All right, well, I suggested that when you do these, you make sure you write your let statement. So I'm going to let x equal the angle, and then 90 minus x equal the complement of the angle. All right, well, this question also involves supplement, so when you have both, it's good to write a let statement that relates to the supplement. Now, this is not the only way to do it, it's just the way I showed you guys when there were complements and supplements in the same word problem. All right, now I just read the question exactly as it's written. The supplement of an angle, so 180 minus x, so is means equals 4 times the complement, so 4 times 90 minus x. And I'm using parentheses so that I realize that the whole quantity is being multiplied. All right, then I just do the algebra. I'm going to distribute, and I get 360 minus 4x equals 180 minus x. I'm going to subtract 360 from both sides, and I get negative 180. I'm going to add x, and that gives me negative 3x. I divide, and I get x equals, what is that, 60? Okay, so x is the angle. I want the complement, which would be 30. Okay? All right, I also gave you some always, sometimes, and nevers, just some reminders and some true falses. You're looking for one counterexample. If there's one counterexample on a sometimes, always, or never, then you're going to go with sometimes. If there's one counterexample on a true false, then it would have to be false. So I'm going to have you try 7 through 14. We'll go over those in class, and the answers are posted on the filled-in note packet. And this is where I want to stop today. I want to stop in the review section. In the review section, I said, hey, make sure you go back and read about midpoint and the segment addition postulate. And we've been talking a lot about systems of equations. So I wanted to see what you could do with this question. So I want you to definitely try this first. Do not let me show you first. I'm only doing this to help you if you really are struggling with it, okay? All right, so if P is the midpoint, you mark your diagram with the given. So P is the middle, so I'm going to mark these guys congruent. And then I'm going to mark and label all the parts of my diagram. So it says MP is 2x plus 3y, and PQ is 5x minus 6y, and the whole thing is 60. Oh no, Coach Fred, I've got two variables. If I wrote an equation for using midpoint, I would get 2x plus 3y equals 5x minus 6y. They're equal, so I can set them equal. But that equation has two variables in it. So that's where I have to have a stop sign here. I got to stop, and I got to think. If an equation has two variables in it, in algebra, you only learned one way to solve that. You had to use a system. A system meant you needed another equation. So this is a place where I can use the segment addition postulate. The sum of the two parts equals the whole. So my second equation would be 2x plus 3y plus 5x minus 6y equals 60. Okay, so I'm going to stop there because I really want to see if you can solve it. So bring the class tomorrow and we'll check it together. Have a great day.